Let's solve this example of triple integration. So this here, the region is bounded by all these curves, okay? And we have to, by considering this region, we have to solve integration, this triple integration, okay? So let us consider the region first. After that, we will go for integration. So see, I will clearly mention given region is bounded by, see, we have a several curves. We will start with the first curve. Here we have inequality, but when we want actual curve, we need to consider equality. After that, by considering that inequality, we will guess the region. Okay. So if I consider equality here, we will have x square plus y square is equal to 1. So this is equation of circle, right? With center, origin and radius 1. So I will clearly mention circle having radius 1 and center is obviously 0. See, actually it's not a circle, it's a cylinder. In 3 dimension, it's a cylinder. In 2 dimension, we can say it's a circle. Getting? Having radius 1. So this is a circle we have. Actually, we have a cylinder in 3 dimensional like this. Getting? But I will not draw a diagram of in 3D. We will simply discuss in 2D. Okay. After that, if you consider equality here, we will have circle again. X square plus y square is equal to 3. So this is again a circle. Can you tell me its radius? Its radius is root 3 because 3 is the square of root 3. So we have a one more circle having radius root 3. Center is origin again. Okay. So this is a second circle we have. Right. Here, if you consider first equality, there is inequality, but I will consider x is equal to root 3y. See, it's a line because power of x is 1, power of y is also 1, so it's a line. See, you remember, no? So when we have a line, we draw a table. Okay, so I will do directly in my mind and I will draw the line. If I put x is equal to 0, if I put y is equal to 0, I will have x is equal to 0. So that means 100% this line passes through origin, right? So yeah, I'm drawing a rough sketch of that line. So that is x is equal to root 3y. You can draw that table and check, huh? No worry. But already we have solved many problems, many videos already we have discussed. Okay, so that's why I'm writing it directly. Here also we can consider equality. So what will I have? Root 3y is equal to 3x. See, you know 3 means root 3 into root 3. So 1 root 3 will get cancelled and we will have y is equal to root 3x. So it is again a line. So y is equal to root 3x. One more line we have and again it passes through origin because if I put x is equal to 0, y also will be 0. So this is my second line. Y is equal to, I will call it as y is equal to root 3x. You can check, huh? You can check by drawing that table. You will have a line like this. Okay. Let us go further. See, region bounded by these two circles. That means obviously this region we have, as well as region bounded by these two lines. That means we have only two possibilities. Either we will have this region or this region, right? Bounded by circles as well as bounded by lines also. So that's why two possibilities, this one or this one. See, but they have added one more condition, that is x is greater than or equal to 0. That means here x should be positive. If you consider this region here, x is negative. So I should consider that region only. Okay. See, dotted lines here to show the region. So the shaded region is a region of integration, right? Next, x is 0 and x is equal to 3. So x is equal to 0. So this is xy plane. This is xy plane. And sorry, z is equal to 0 and z is equal to 3. That means a plane parallel to xy plane. So simply they have mentioned the height. Okay, so this is a region cylinder having a base, this one, and we have a cylinder like this having height. Okay, it starts at z is equal to 0, that means in xy plane, and it finishes at z is equal to 3, at a height 3 it finishes. So we have a cylinder like this, having base this region. Okay, so when we have a cylinder, we use cylindrical polar coordinates. Using xyz also we can solve the problem, but if you convert it into cylindrical polar coordinates, we can easily solve the problem. So let us convert it into cylindrical polar coordinates. Okay, to convert, I will clearly mention, to convert the problem into cylindrical cylindrical coordinate system what we put x is equal to r cos theta, y is equal to r sin theta, and z is equal to z, right? And you know that dz dy dx, this is equal to r dz dr d theta. So you know that when we convert the problem in cylindrical polar coordinates and we use this substitution, our first task is to convert all equations in terms of r theta and z. So let us start to do. So we have x square. What is the first equation? X square plus y square is equal to 1. So you know that x is equal to r cos theta, y is equal to r sin theta. So let us put r square cos square theta plus r square sin square theta is equal to 1, right? So r square we can take common, cos square theta plus sin square theta 1, so that's why r square is equal to 1. By taking square root of both sides, what will we have? R is equal to 1. So equation of inner circle is r is equal to 1. Okay, so let us think about outer circle. We have what is the second equation? X square plus y square is equal to 3. So this is the second equation, right? So same thing, same procedure we can apply. And what will you have at the end? Tell me. R is equal to root 3, right? You can apply the same procedure. X means r cos theta, y means r sin theta. By taking square root here, we will have r is equal to root 3. That means equation of outer circle is r is equal to root 3 in polar coordinates. Okay, so see, after that we will convert these two equations also in terms of polar coordinates. But before that, I will suggest you to make a screenshot of this. Okay, after that we will go further. See, now we have a line, getting? So we have x is equal to root 3y. So let us convert it into cylindrical polar coordinate. X is equal to r cos theta, correct? Y is equal to r sin theta. So r will get cancelled. Cos theta is equal to root 3 sin theta. I will shift root 3 on this side and cos theta on that side. So 1 upon root 3 sin theta upon cos theta tan theta. So can you guess the value of theta? At what value of theta we have tan theta is equal to 1 by root 3. It is pi by 6. Okay. So see, equation of this line x is equal to root 3y, that is theta is equal to pi by 6. After that, we are going to find equation of this line in cylindrical polar coordinates. Y is equal to root 3x. See, now y is equal to root 3x. So repeat the same procedure. Let us repeat. Y is equal to r cos theta, r sin theta. Okay, just a minute. Root 3x is equal to r cos theta. R will get cancelled. So sin theta is equal to root 3 cos theta. So let me take this cos theta on this side. So sin theta upon cos theta, we will have tan theta. So therefore, tan theta is equal to root 3. So that means value of theta should be pi by 3. So value of theta here, theta is equal to pi by 3. So I think now we can easily find limits here. Okay, our strip always in polar coordinates, strips always starts at origin, but strip will be like this. Okay, I have drawn here dotted strip. Okay, since that region out of the region of integration, so that's why dotted strip. And here I will show the complete shaded strip. So then limits, first we write limits of z, then r, and at the end theta. So limits of z they have clearly mentioned, right? So z varies from 0 to 3. When we have a cylinder, obviously we starts at bottom of cylinder and we finishes at top of cylinder, so 0 to 3. Next, r. So actually region starts at inner circle and it finishes at outer circle. Strip is bounded below by inner circle and bounded above by outer circle. So here the equation of inner circle is r is equal to 1 and equation of outer circle is r is equal to root 3. Getting? And the strip will move like this. It will start at theta is equal to pi by 6. It will rotate like this and it will finish at theta is equal to pi by 3. So limits of theta will be pi by 6 to pi by 3. Then, okay, I will write there, since now we have to solve the integration. So then I will make a partition here. Then I is equal to triple integration, limits of theta pi by 6 to pi by 3, limits of r 1 to root 3 and limits of z 0 to 3. And what is the function we have? We have z upon 1 plus x square, that means r square cos square theta, plus y square, that means r square sin square theta. I will write it here, into we have, see this function, into dx dy dz. That means obviously we have r dz dr d theta. Okay, so you can make a screenshot of it and after that we'll go for remaining part of this problem. Okay, so let us solve this problem. I is equal to integration pi by 6 to pi by 3, here 1 to root 3, here 0 to 3. See at numerator z into this r we have. So zr upon 1 plus. See what will happen here, r square cos square theta plus r square sin square theta we have. We can take r square common. So cos square theta plus sin square theta 1. So I will skip that step and 1 plus r square I will write directly dz dr d theta. So as you know, first we integrate with respect to z. So this is equal to integration pi by 6 to pi by 3, 1 to root 3. See, terms of r are constant if you integrate with respect to z. So that's why r upon 1 plus r square will come outside. R upon 1 plus r square. So simply integration of z dz and after that we will have dr d theta. I will remove that step. Okay, it is not required now. Just a minute. Okay, so this is equal to integration pi by 6 to pi by 3, 1 to root 3 r upon 1 plus r square. What is integration of z? Z square by 2, 0 to 3 dr d theta. I will put upper limit first. If I put 3, we will have 9 by 2, correct? If I put 0, we will have 0. So 9 by 2 is a constant. We can take it outside. 9 by 2, pi by 6 to pi by 3, okay? And 1 to root 3 r 1 plus r square dr d theta. See, to solve this integration, I am going to use one result. That result is integration f dash of x upon f of x dx is equal to log f of x. So to use this result, what we want derivative of denominator at numerator. What is derivative of denominator? Derivative of denominator is derivative of 1 is 0. Derivative of r square is 2r. So only out of 2r we have r. So I will adjust 2. What I am going to do, I will divide and I will multiply 2 and here 2. So that's why I divided by 2, I have multiplied by 2. So now I can apply that formula. So this is equal to 9 by 4 integration pi by 6 to pi by 3. Okay. By using that formula, log of denominator. So log of 1 plus r square with limits 1 to root 3 d theta. Okay. Okay, so let us continue. So this is 9 by 4. Okay. 9 by 4, and integration pi by 6 to pi by 3. See, I'm going to put upper limit there, huh? Log. If I put root 3 here, root 3 square is 3. 3 plus 1, we will have 4, minus, I will put lower limit. If I put 1, we will have 1. 1 square is 1. 1 plus 1, 2. Okay, and after that, d theta. You know that log A minus log B. What is it? It is log A divided by B by property of log, correct? So I can apply that for this property of log here. So this is 9 by 4 log 4 by 2 by this property of log. As well as this is a constant, so we can take outside the integration. So that means in integration we have simply pi by 6 to pi by 3 d theta. So this is 9 by 4 log 2 to cancel log 2 integration of theta d theta is theta pi by 6 to pi by 3. Okay, I will remove this formula. We have used them, it is not required now. Yes, just a minute. So this is equal to 9 by 4 log 2. Okay, I will put upper limit pi by 3, lower limit pi by 6. So pi by 3 minus pi by 6, you can cross multiply or you can make a denominator saying we will have answer pi by 6. So 9 by 4 log 2 into pi by 6. So let us multiply. 3 will get cancelled. 3 and here 2. So this is 3 pi log 2 divided by 8. So this is required answer. Okay. You can make a screenshot of it and after that we will stop. Thank you. Bye bye.